Hi, I'm Philip, and in this video I will show you the on-device scan workflow with the Sermoon P1, like scanning this, my trusty anatomical head you may already know from other tests, and then also the meshing, the alignment of multiple scans, because to scan the full head I will need to scan it from the top and from the bottom, and then of course the meshing. I will look at the speed of the processing in comparison to the processing on the PC itself. So I will redo the processing on the PC and then we can compare the time it takes. And I will also do the similar test with the scan ritual in the near future. So for the scan setup, I of course have the Sermoon P1. I installed the latest firmware update, so the update for the version v1.0.9, I think it is, came out a few days ago. So initially it was 0.0 something, and with the new version it got a lot more stable while scanning. And for the head itself, you can see I placed it on my turntable. I have marker points on the turntable, and I use these marker geometries all around the head to just have better tracking, especially when I go lower. So normally you all want to see your markers from the top, but with the marker geometries I can also scan from the side like this. Normally nowadays I often leave the turntable at home or don't use it, because I noticed that especially high resolution scans, or if I move around quite quickly in the turntable, the scan object can move. So I switched mostly to marker cards. So these are basically black aluminum business cards. I glued roughly 5 to 6 markers on each in a random pattern, or I at least tried to glue them in a random pattern. And then I can just lay them around the object I scan. And as you can see here, these are, I think, 40 pieces. And they quite comfortably fit in the original carrying case. For the second scan, when turning the part upside down, I will be using some blue tack to fix it so it doesn't move. But to be honest, I noticed that blue tack sometimes is the wrong choice, because it can have some give, so it can sag over time. So maybe I will experiment around a bit with a proper clay, or like modeling clay, which could be a bit more stable. So the blue tack is a bit of rubbery sometimes, but I guess I still have to search for better alternatives. Now let's unlock the scanner, and I can now start the screen capture here on the scanner itself. For a new scan, basically you press a new project, and for this test I will just let it at the default settings. So the default settings are the laser mode, as you can see here. Direct point cloud scan. For the laser types, you can use cross lines, parallel lines, or single lines. To start with, I will use cross lines, and then for the deeper crevices, like in the nose or the eye sockets, I will switch to a single line mode. For this test, I won't remove the base plane, and I will let the resolution at 0.5 millimeters, because this makes the scan process a bit faster. So my main interest is the post-processing speed, and I guess 0.5 millimeters is, I would say, one of the most common resolutions I settled at for a bit larger parts. So this may be like the smallest part I would scan with 0.5 millimeters. I will redo the scan at 0.1 millimeters and upload it to Sketchfab also, but then simply the data capturing takes longer, and I may even prefer scanning it connected to a PC, because then the frame rate is higher. So on the scanner itself, when scanning, the maximum scan rate is advertised at 60 FPS. In single line and parallel line mode, it often reaches this frame rate. In parallel lines, it can dip a bit lower. It really depends on what you're scanning and how much data it must process. But so I will leave it here. One additional point you have to remember on the scanner: if you change any setting, you have to press the apply button to make them into effect. Otherwise, you may wonder yourself why the settings didn't change, even though you played around with the sliders and the buttons. For exposure, let's maybe have a look. The automatic exposure actually looks quite right. Maybe it's a bit on the brighter side. So as you can see, you don't want all your lines to be blown out, so overexposed, but this actually looks quite good. We're capturing a good amount of markers. Maybe the scanning range can be edited here, but I will just leave it on the full range for very high resolution scans with the parallel modes, parallel lines. You may want to reduce them, but not here. And the default is data quality mapping, that's fine. But now, as you can see, it's exposing quite brightly. So I will actually do the manual. And this looks good. So I guess we can start scanning now. And as you can see, at 0.5 millimeters resolution, the scanning itself is very fast. So even with the 22 laser lines in comparison to like the Sermoon S1, the PC connected scanner, I would call it, it's still very, very fast. And currently I'm hitting now 32 FPS, 35 FPS. But if I am now going to switch to the parallel lines and the single line, simply by double pressing the scan start button, you can see the switching is actually like nearly instantaneous. So that's quite enjoyable. But most benefit will the single line give. And as you can see, I'm getting down into the eye sockets quite nicely. Same applies here for the nasal cavities and for the separating cartilage in the nose. So keep in mind, this is like a plastic reproduction of a head, so it is no real head. So some people maybe seem to forget this or don't really understand it. And I've got some quite interesting messages about how I can got my hands on a really human head. But so this is scan number 1 nearly finished. So maybe a bit more here into these deeper cavities. And now let's switch back to cross lines. And actually on the camera, I think you're only seeing one of the crosses or one of the sides, but this should do it. And now I can just finish this first scan. Let's have a look. Okay, here's the quick start menu because I just updated the firmware and reset it. And now the first set part I will be doing is actually deleting the unnecessary additional data here in the scanner, because I don't want to process the data that I am not going to need. This simply saves a bit more of the PC resources, or resources while scanning or while post-processing. And now let's edit, and it's quite snappy. As you can see, it feels quite snappy, and with the latest update, it improved a bit, or it improved quite significantly. So the first scan is done. Now let's do the next scan. And for the next scan, I will simply turn the head upside down and place 3 small parts of blue tack here, just so the head doesn't move around when placed on the upside down. Otherwise it would be quite unstable. But I will also try to not move it around too much in this position, because then the blue tack may be a bit unstable. So let's see. This looks good. So we can just start with the scanning. And I already captured most of the data of the sides, so I guess one fast pass around will be enough. And I'm very carefully moving the turntable. So if you have like these unstable scan setups, you really don't want to move around too much, to move around in jerky motions or very fast motions. Just be gentle and patient while scanning. And now I will even stand up, and I may be a bit at the limit of marker tracking here, as you can see. So I basically have to try scanning a bit from the side. I think on the camera it isn't observable too much, but maybe on the display. So if I go to the side, I regain tracking with the markers. And if I would scan straight from the upside down, the tracking would be lost. So maybe a bit more here to the deeper crevices. And just like this, I think I'm nearly finished. So maybe let's try capture now the space right between, or right here at the top of the mandibular. There is like a spring, a metal spring that that connects the upper and lower jaw. And right behind, it's quite hard to capture the scan data, especially without single line mode. So for these scans, the single line mode is very handy. And I'm quite happy they added it to the P1. So yeah, hopefully other manufacturers will also do this in future products. Okay, now looking quite good, so I can finish the scan. Again, start by deleting all the unnecessary data, like this. And then we can start with the post-processing, which, for which the first step is fusion, before I can align. For fusion, I will just, don't talk to you too much and just let the software run. So the fusion finished, and as you can see, we now have two scans, one from the bottom side and one from the top side. Here on the bottom side we have, or on the top side we have like a small outlier I want to cut out, so just delete the data here. And now I think we can directly go into the alignment. You may have noticed, like here on the side, it's a bit rough around the side. So this is mainly due to the fact that I moved quite quickly to the side, so my focus was on capturing the bottom with like all these deeper crevices. Keep in mind, this video isn't meant to try to capture the highest detail or the best scan. I want to show the processing workflow. I will also upload a high quality version of the scan, where I take a bit more time while scanning, but it will be quite boring to look at. What you also can see for the single scans here, you can directly look at raw data, you can look at diffuse data, or you can also have a look at all the markers that were captured for the alignment. This applies, of course, to both scans. And what I quite like for the processing here on the scanner itself, it's like very similar to the PC version. It's quite fully fledged. So if you can now see and select both scans for the alignment, you have like automatic and manual alignment. And for the automatic alignment now, you can either do a feature alignment or you can even do a marker alignment. I won't be doing the marker alignment now because, as you can see, I didn't delete all the markers on the base plate. And in the marker automatic alignment, it would align the base plates, because only the few markers on the head itself or on the skull itself aren't sufficient. So now let's just do a quick alignment. Won't take very long, and I guess it should work quite good. So yeah, this looks good. So now let's go out, and the next step is directly the meshing. My goal will be to have like, yeah, 1 point. So now, as you can see, both combined have roughly 1.2 million triangles. So I will also set this as my goal. Roughly moving, I will leave the smoothing and boundary smoothing to none. Remove islands, none. Remove spikes, none. And yeah, the hole filling I will leave on for the, so 5 millimeter perimeter size is like very, very small. It's not nearly like pinholes. So they can be filled. So now the meshing won't take very long, I guess. With the Creality Scan software or the Creality scanners, there was like a bit of a change introduced a short time ago, or with the last major software version, where they basically changed behavior. So now the fusion step itself already generates the mesh file. So you can fuse and directly export the STL. So you don't need to do an explicit meshing step. If you want to do the meshing again, you can do for like smoothing, for reduction of the triangle count, but it's not necessary. So the meshing itself is quite fast because it's basically only remeshing. So now we can see the finished skull, and I would say it looks quite nice. Of course, it's at 0.5 millimeters resolution. So the target wasn't to capture the highest resolution, but looking at the inside of the nostrils and in the eye sockets, we captured quite a lot of data. Same applies here for the bottom side, of course. We managed to go all the way into the frontal teeth. How they call it in English again? So I'm sorry, like I'm not a native speaker, but yeah, quite happy. And now let's do the post-processing on the PC. But first, let's share the mesh file, so I can now connect my scanner to the PC and just export the mesh. For wireless sharing, which I will be using, the scanner basically creates a Wi-Fi hotspot, like with the wireless scanning feature. And then you join this Wi-Fi network with your PC. It's like the scanner simply, you get a pop-up, join now on the scanner, and here is the password to the Wi-Fi. On the PC, you also need to open Creality Scan software. And now it is directly popping up here. It's desktop, where my host name of the PC is desktop. I can just press share now. And it first will compress the data. So it can be, I think it is sent as like a archive format over network. This may take a few seconds. And after compressing, it's sharing. Now you can see it's transferring at, yeah, actually quite, damn, the last update drastically improved sharing speed. So with the 0 something version, I initially had, the sharing speed was like 5 megabytes per second, and it was a bit frustrating, I would say. And as you can see, it just topped out at 120 megabyte per second. So this is over a gigabit, over a gigabit per second of Wi-Fi speed. And it directly opened the project on the PC, and I will now be switching to the PC view. This is the direct view I'm getting after import, sharing the project from the Sermoon P1. And as you can see, I have my mesh file, but I'm also having the two single scans. And as I said, I will redo the processing to get a speed comparison. As with the first one, I will leave it at the standard settings. So theoretically, there is like a fast setting, but I won't be using it now, simply because I'm not having it on the scanner, and personally, I haven't used it for any scans, I must confess. What I heard, it's like a bit worse detail. And it does like a bit less of optimization, but maybe I need to dig into the software a bit more and into the settings. And as you can see, it's already finished. So now let's maybe trim again some unnecessary data. This one. And then, yeah, here you also have like some around the jaw. Just delete the data. Then I will again be doing the alignment. So I now select both of them and I can align. I will use the automatic feature alignment again. So here you can also now select between feature and marker. So this, I guess, what was also introduced a short time ago. And I can mesh at 1.2 million triangles again, leaving all settings at default. So you get a bit of a comparison between the speed. Sadly, with the latest update in Creality Scan, I noticed some issues in HDR. Like the screen is flickering a bit now, right now. You may not see it, so I'm like, the capture is forced in SDR, so no HDR artifacts, but I guess they need to do a bit of optimization. And yeah, you can see the mesh is finished. I guess it looks quite the same from the scanner itself. But yeah, so I will add the speed or the timing in the video description.